Hey, today we're going over section 5.9, complex numbers, powers of I, and conjugates. The only piece we have left to discuss is dividing of complex numbers. We'll discuss that definition and then look at problem number 7. Okay, how do I divide a complex number? Basically, you don't want I in the denominator. And so dividing a complex number is kind of like rationalizing the denominator. Do you remember when we did this before, when I had 3 over the square root of 2? Remember that you multiplied by root 2 over root 2? Hey, I'm not doing anything wrong. I'm just multiplying by 1. Anything over itself is 1. So you multiply by root 2 over root 2 in order to rationalize the denominator. So this would become 3 root 2, and then into the denominator, root 2 times root 2 squared, so it undoes each other. You just get 2. That's the same kind of idea when we're thinking about dividing complex numbers. So it's not a process like long division or something we've thought about before with whole numbers. It's more like the process of rationalizing that denominator. How do I do that? In this case, I just multiplied by root 2. But then what happens if it's more complicated, like root 2 plus 1? I can't just multiply by root 2 because then I'd have to distribute and get another root 2. Ah, that's when we come up with something called the conjugate. Remember, you multiplied by the conjugate. So I still multiply by 1, but now it's root 2 minus 1 over root 2 minus 1. Anything over itself is 1. I'm not doing anything wrong. I'm just manipulating it to get what I want. Just like water, ice, vapor, changing the form, but it's still the same components. Okay, now remember how we did this? We would distribute the 3. So this would become 3 root 2 minus 3. And then in the denominator, what happened? When I distribute, look, a plus b, a minus b, I don't need to distribute. I can use the difference of squares pattern. I know that this is a squared, so root 2 squared, so 2, minus b squared, which is 1. So 2 minus 1. That's how you rationalize the denominator when you have just one square root or when you have a square root added to something. You cannot just multiply by root 2. You need the conjugate because you need those middle terms to add to 0. And that's exactly what happens when you force the pattern of the difference of squares. If you've remembered that process from before, that's it, you're home free. It's the same idea with imaginary numbers. Let's look at problem number 7. 5 over 6i. Divide means to get I out of the denominator. So how do you get rid of that? Why don't I just multiply by I over I? Just like our first example, we don't need a conjugate. We just need that one square root so it can undo each other. Same idea here. What's I times I squared. -1. It's no longer imaginary. That's what we're doing here. So I see that this becomes in the numerator 5i and in the denominator 6i squared. Remember, you never write I squared, you write -1. So this becomes -5 6 I. No i's in the denominator. All right, let's try B. 2 over 7i. Same process. You don't need a -6 or a -7. You just need an I. So multiply by I over I. And then I see that this gives me 2i over 7i squared. And then I remember that I squared is -1. And then I write my answer. So -2 over 7i. And that's okay if you take the I kind of outside, out of the numerator, and just put it over there. Perfect. Now it gets more complicated for C and D, but we've done this before right up here. It's the same kind of idea. What's the only difference? The only difference is instead of using a squared minus b squared, down here we have an I. So it's a squared minus b squared I squared. Instead of saying a squared minus b squared I squared, let's just change I squared to -1, and negative times a negative, we'll just change it to a squared plus b squared. So anytime you multiply by the complex conjugate, you just use the pattern a squared plus b squared, and you don't have to worry about plugging in the I. Awesome. Let's do these two. Remember, the conjugate is for the denominator. I don't care about the numerator. What I care about is getting it cleaned up in the denominator. So you write exactly what you see, but you change the sign in the middle. So for C, we would have 3 plus 2i over 3 minus 2i. Don't forget, if you have these binomials like in C, you've got to go through and distribute all of that. So this would be 5 times 3, so 15, and then 5 times 2, so plus 10i, and then take through the negative I, so minus 3i, and then minus 2i squared. Once again, always aware that the next step, we're changing this to -1, which would make this whole term plus 2. Okay, just be careful of your signs. It's just a really common error for students. So be careful, be organized, you're good. In the denominator, oh no, should I distribute? No, I should use my pattern. This is a minus b, a plus b, and I have the I there, so I'm just going to use a squared plus b squared. So 3 squared plus 2 squared. Awesome. Let's combine like terms and clean this up. I have 15 plus 2, so 17, and then 10 minus 3, so plus 7i, and then divided by 9 plus 4, so 13. Am I done? Should I box it? No, you've got to leave it in the form a plus bi. Okay, so make sure if you have a fraction like this that you separate it into 17/13 plus 7/13 I, a plus bi. Keep it organized. All right, why don't you try D and then come back and see how you did. Did you figure out the conjugate? So 2 minus I, and you multiply by 2 minus I divided by 2 minus I, because anything over itself is 1. And then you would distribute in the numerator and use our special pattern in the denominator. So I take the 6 through. 6 times 2 is 12, minus 6i, and then take the negative I through, so minus 2i, and then plus I squared. Once again, just remembering the I squared is -1, so this would become -1. In the denominator, we use our special pattern. Since we're dealing with I, we know that it's a squared plus b squared. What is b? It's just 1, so don't be confused. Notice this would be 2 plus 1i. Anytime there's a 1, we don't write it. We know that it's a 1. So this would just be a squared plus b squared. And then we combine like terms. So 12 minus 1, so 11, -6 minus 2, so minus 8i. And then divided by 2 squared plus 1 squared, so 4 plus 1, so 5. And then we separate it. So 11/5 minus 8/5 I. Always in that final format, a plus bi. Now you know all about complex numbers, how to add, subtract, multiply, and finally, what does it mean to divide? You're just cleaning up the denominator and making sure there are no imaginary numbers in the denominator. Thank you so much. Keep on keeping on. See you later.